Hey guys, and welcome to how to graph and analyze any quadratic. So suppose you are given a quadratic and you're asked, hey, can you graph this thing? And I also want you to tell me where the vertex is. I also want you to tell me where the X-Intercepts is. I also want you to tell me where the Y-Intercepts is. I want you to come up with a min and a max for this thing. I want you to tell me where it's increasing, and I want you to tell me where it's decreasing. So all of that is under analysis, okay? But before we analyze, we have to first graph or draw our picture. So before we get started in all this, there's a couple things we just have to kind of know innately about parabolas. So the first thing is their shape. So this is our axis. The shape of these guys is a U. They can be a U facing upwards or concave up. They can be a U facing downwards or concave down. They're either up or down. There's no like sideways parabola going on here. Okay. They have a couple defining features like a vertex. Right? This would be this guy's vertex. So they have a vertex, which is like the pinnacle of where they kind of either meet in the middle. It's the axis of symmetry. So they have an axis of symmetry. This guy's axis of symmetry would be there. And the axis of symmetry is where can I perfectly fold this parabola onto itself. So parabolas, they open up, they open down. They have a vertex, they have an axis of symmetry. They are decreasing along certain parts, increasing along other parts, or increasing along certain parts, decreasing along other parts. Some of them have X-intercepts. Some of them don't have X-intercepts. They all have Y-intercepts at some point. Let's see, what else do I have in my notes here that we need to know right off the bat about parabolas? Nope, that's it. Okay, so general shape of parabolas. Now, how do we create these very beautiful pictures that I have here? Well, we get all the information that we need from the equation. That's kind of the point of the equation. The equation is like, hey, here's like the computer program algorithm of what you need to do to graph. All the information about these parabolas from negative infinity to positive infinity is encoded in these equations. Okay, everything you need to know is here. But now we need to figure out, okay, well, how do I pick out that information? How do I create my graph or my picture? And then once I have it, how do I analyze it and pick out my relevant pieces of information? We'll see in a future video what these relevant pieces of information mean, like in the real world and not just right here on a whiteboard with H's and K's and X's. Each piece of information is important for a particular aspect depending on what you're doing. But again, we'll see that in a future video. So we know what these things are going to look like. So now the question is, how do I pick out my relevant piece of information to make my parabola if I'm just given things that look like this? Well, in kind of general form, I don't know. We have to do some work. But in standard form, or also called vertex form, I can very nicely pick out my H and my K here, and this will give me the vertex. Most of the time, you will see quadratics in the first form. Very rarely, unless you have a very nice and neat, somebody has already kind of prepackaged this thing for you, will you see it in your vertex form. More likely than not, you're going to see it like a trinomial. So that's the form we're going to look at. If you happen to get it in this form, your vertex of your parabola, remember that like pinnacle point, whether it's up or down, is going to be at H, comma, K. In this case, take the opposite number here and take the same number here as far as signs go. So our working example that we're going to use, so what if we have, what? What do we have? Okay, f of x equals negative 3x squared plus 6x minus 2. My notes are in the floor. I'm not just like, tell me all the information. That's what I'm looking at when I look down there. Okay, so here's our a, x squared plus bx plus c, even though it says minus. So before we start, let's pick out our a, b, and c because we're going to need these. So a is negative 3. B is positive 6, and C is negative 2. So the first thing I'm going to do, I want to graph it, and then I want to analyze it. The first thing I need, and what you always need when you start, and the most relevant piece of information for any parabola, is the vertex. The vertex is literally the pinnacle point. So if I have a graph here, and excuse my artwork, I'm going to really make this kind of zoomed in. Okay, so if I have an axis there and I'm given that equation, how do I make that equation into one of these beautiful U's and put it here? We need some pieces of information. The first thing we need is we need to pick out the vertex. So the vertex of a parabola or of a quadratic when it's in ax squared plus bx plus c form is, and stay with me, negative b over 2a, sorry, negative, comma, f of negative b over 2a. What does this mean? X coordinate of the vertex, comma, y coordinate of the vertex. This is kind of an algorithmic form of if we went from here to here. And it picks out our h. But what is this? Well, how do we find the y value given any x value? Like imagine you're making the t-chart. Well, what do? We plug in the x. So I plug in whatever I get here into my function everywhere I see an x, and that's going to spit me out the y value. That's why this notation looks the way that it does. So what is our vertex? So our vertex equals something, comma, something. Okay, how do we figure out what that is? Well, let's go through the negative b over 2a. So negative b over 2a. Negative b for us, so b is 6, but negative b will be negative 6. 2a, a is negative 3, 2 times a. Let's see, that'll evaluate to negative 6 over negative 6, better known as positive 1. Okay, the x-coordinate of my vertex then is equal to positive 1. Y-coordinate of the vertex, though, how do we figure this out? What does f of negative b over 2a even mean? Oh, it just means figure out your x-coordinate first and plug it in, and then you'll get your y-coordinate. So let's plug in 1. Okay, so what is f of negative b over 2a? Well, this is really, okay, just plug in 1 to our function. So what does it look like when we plug in 1? All right, it's going to look like negative 3 times 1 squared plus 6 times 1 minus 2. Okay, orders of operations. 1 squared is 1, times negative 3 is negative 3. 6 times 1 is 6, minus 2 is minus 2. Negative 3 plus 6 is positive 3. Positive 3 minus 2, hopefully I need to put down the correct 2 fingers. 1. Okay, so the y-coordinate of my vertex then is also 1. So my vertex is going to occur at the point 1, comma 1. So I go to the point 1, comma 1. Now I also know about this, that this is my axis of symmetry. The vertex always sits at the axis of symmetry. So since that's my vertex, the axis of symmetry, is the line x equals 1. There's the axis of symmetry. Once you find the vertex, you know where your parabola is symmetrical with respect to. Okay, so we've figured out our vertex. And with our vertex, we gain the information about our axis of symmetry. Okay? Well, if you're anything like me, this isn't enough to draw a parabola because we don't know how thin or skinny or stretched or compressed It is. So I can't just go through and draw you through that point yet. I need a little bit more information because is this a really skinny parabola? Is this a really wide parabola? The only thing I know right now is that's where my vertex is, that's where my axis of symmetry is, and I also know that this guy's facing down. If your lead coefficient is negative, this is an upside down parabola. So I need to dig in more information, like possibly, okay, this guy's facing down, so maybe what are my x-intercepts then? That'll kind of help me with how fat or skinny. So x-intercepts. X-intercepts. So x-intercepts occur when you set your function equal to 0. So for what x's do I get when I set my function equal to 0? Okay, let me set my function equal to 0. 0 equals negative 3x squared plus 6x minus 2. Okay, how do we solve this now for x? Oh, quadratic formula. Here's our a, here's our b, here's our c. Let's get going. Quadratic formula, negative b plus or minus the square root b squared minus 4ac all over 2a. Okay, let's plug our pieces in. And I'll put this over here. Our negative b is 6, so negative b is negative 6 plus or minus the square root of b squared. B is 6 again, so b squared is 36, minus 4 times a times c all over 2 times a. Okay, just plugging our pieces into quadratic formula. All right, now let's simplify. So we get negative 6 plus or minus, let me complete that 6. 36 minus, okay, negative times negative is a positive, so that's positive 6 times 4. So it'll be a 24 there. 2 times negative 3 is negative 6. Okay, if we simplify this a little bit further, plus minus square root, that's going to be a 12 all over negative 6. Okay, and here is where we are going to pull out our calculator. Okay, so our x-intercepts are going to be at, and I'm just going to throw both of these in the calculator and kind of see what we get. Whoa. So our x-intercepts are at, so negative 6 plus square root of 12, negative 6 plus second square root 12 divided by negative 6. So 0.4, I'll just go 2 decimal places, 0.42. And now let's do the subtraction. Negative 6 minus square root of 12 divided by negative 6, 1.58 rounded off. Okay, so quadratic formula got us our x-intercepts. Thank you, calculator. Okay, so our x-intercept is going to be at 0.42. That's like, it's a little less than a half. So here's a half. It's a little less than a half. So it's like there. And then 1.58, that's like 1.5. So here's 1. Here's like 1.5 here. Okay, so I know that I go, let's see, do my best. And, okay. So I know that so far, but now what about the tail pieces? Okay, for this I'm going to use my y-intercept. How do I find my y-intercept? Well, my y-intercept is not found when I set my function equal to 0. My y-intercept is found when I plug in 0, and then I see what I get. So let's do that, and let's see, plug in 0 for our function, so f of 0. F of 0 will be equal to negative 3 times 0. We're going to see all the 0 pieces are just going to disappear. Plus 6 times 0 minus 2. So f of 0 is equal to negative 2. So our y-intercept then is going to be at negative 2, or y equals negative 2. So our y-intercept is equal to negative 2. So negative 2 for us is here. Okay, so let me do my best here. This is going to be a little skinnier than I thought. through there, and keep going. Through there, let me try to make it as symmetrical as possible, and keep going. Okay. That is not a tick mark. Let me get rid of that. Kind of clean this up a little bit. There we go. Okay, so that's the general shape of my parabola. And we also fill in that we knew the vertex is at 1, 1. Axis of symmetry is there. Our y-intercept is at -2. Our x-intercepts are at 0.42 and 1.58. Okay, so we graphed. But now let's analyze, because there's a couple things we would like to know. Like, for instance, where are we increasing? And where are we decreasing? So we are increasing and decreasing. These are all x intervals. So my graph is increasing if I'm coming in hot from the left. My graph is increasing from a -infinity all the way up until 1, okay? Left to right. We're increasing from -infinity to +1. We're increasing from -infinity to +1, okay? Infinity always gets a curve, whether it's negative or positive, and we're actually going to go to 1. Now, where are we decreasing? We're decreasing now from 1 to +infinity, right? From here all the way out. We're going to be decreasing forever. So we're decreasing from now 1 to +infinity, and +infinity gets a curve. Okay, the other thing I want to know is maybe where's my max? And where's my min? Okay, maxes and mins are super important. Okay, where's my max? Okay, max, highest point. Where's the max on this graph? It's here at y equals positive. It's right here, y equals 1. So my max is at 1. So my max, y equals 1. My min, well, those arrows go forever. So my min, I'm gonna go forever. So I'm gonna go forever in the negative direction. So my min is, some people will say, well, we don't have a min, but it just goes to -infinity, so we never actually get there. The min is -infinity. We don't have a minimum. It goes down forever. Now, if this was facing the opposite way, then we wouldn't have a max, because our max would be +infinity. It'd be going on forever in that direction. So, how to graph and analyze any quadratic. So you'll get a quadratic in either of these forms. If you get your form in this way, congratulations, you can pick out your vertex and then you can go the rest of your way. You get it in as a trinomial, then pick out your A, B, and C, find your vertex, find your intercepts, find your x-intercepts, find your y-intercepts. At that point, create your graph. Where is it increasing? Where is it decreasing? Sorry. There we go, now we're done with that bell. Where's the max? In other words, where's the highest point in the parabola? And where's the min? Where's the lowest point in the parabola? And we won't necessarily always have one. Also, another note, we won't necessarily always have x-intercepts, because what if our graph is an upward facing U up here? We won't have any. We will always, however, have a y-intercept. We will always have an increasing area. We will always have a decreasing area. And then max or mins, it depends what direction you're facing. So I hope this helped, and as always, let me know if you have any questions when you're done.